Hello, my dear students. In this lesson, I'm going to tell you what we have for the second semester at the grade 10. Chapter 5, 6, 7 left. Chapter 5 about reflection and light properties. Chapter 6 is about the refraction and some mirrors. And chapter 7 it's about polarization and mixing colors. The first section from chapter 5. And section 2 also second section from the chapter 5. First of all, we finished the chapter 4. We are about to do an exam about it. Now we are at the chapter 5. And the chapter 5 it's about light reflection, and chapter 6 it's about the refraction, and we're gonna have chapter 7 and the last chapter. It's about polarization and color, mixing the colors. So easy. Now I'm going to review the first section from chapter 5, properties of the light. And let's get started. I think we did we did explain the first section, but I'm going to do a quick review about it. And this section, it starts with electromagnetic waves. We said that electromagnetic waves, it's a kind of wave, it's a combination of the electric field and magnetic field together. That's why we call them electromagnetic waves. And there is 7 different types of electromagnetic waves, we are going to classify them, and we're going to have the range and applications about the electromagnetic wave. That is the kind of model which is we call electromagnetic wave model. We have 2 fields, as you see, the electric field and magnetic field. This electric field and magnetic field, and they are oscillating, and the angle between them is 90 degrees. And here is the definition of the electromagnetic wave, which is the wave that consists of oscillating electromagnetic field, which radiates outward from the source at the speed of the light. The speed of the electromagnetic wave is the speed of light, we know that speed of light equal to speed of light equal to 3 times 10 to the power 8 meter per second. You know that already. And also we will have this property we will explain later. This kind of shape we will explain later. And then let's go ahead with the property. Electromagnetic wave depending on the frequency and wavelength. Which as we explained before. From this graph we can understand the frequency and the wavelength. Let's just make it smaller. Okay. Look, from this point, let's change the color. From this point to this point, we call it the distance between 2 similar adjacent points, is going to be equal to 1 wavelength. It's going to be equal to 1 wavelength, guys. And from this point, equilibrium position, we call it this line we call it equilibrium position. From the equilibrium position to the maximum point we call it crest. This is also crest, another crest. The distance between 2 crests, it's going to be 1 wavelength. It's going to be equal to 1 wavelength. Okay, it's going to be equal to 1 wavelength. That's the wavelength. You know that from this point to this point, the minimum point we call it throw, and the distance between equilibrium position to the highest point we call it the distance amplitude. We call it amplitude. Okay, the distance between equilibrium position to the maximum point we call it amplitude. Frequency is equal to the number of waves which is passing in a point in a given of time. The classification of the electromagnetic wave, which is we call it electromagnetic wave, and it has a speed of light. Electromagnetic wave, it has speed of light, and in the electromagnetic wave there is a nice explanation about that, which is nice, an important note, which is for electromagnetic wave we don't need anything to transfer through it. It means that if there is a air, if there is a water, if there is a whatever, solid, liquid, gas, if there is nothing, in this case electromagnetic can go through them. We know that the light is coming from the sun, and between the earth and sun there is a vacuum, so it goes through the space. So it means electromagnetic wave doesn't need a transformer, but mechanical waves we need medium for them. For example, for sound we need a medium. If there is no air between two guys, they cannot hear each other. They cannot understand what they are saying. Okay? Because we need air particle to transfer the energy, the sound energy. And we call this energy is mechanical energy. We call this wave mechanical wave. Okay, so for electromagnetic wave we don't need a medium. Okay, and first wave we are going to have from the electromagnetic wave, we call it radio wave. The radio wave, the wavelength, the length of this wave, it starts from 30 centimeter, and the frequency of it is 1 times 10 to power 9. Okay, and where we can use the radio wave, you know, that AM or FM radio or television. The second one is microwaves, and the microwaves, the range of this wave is equal to it's between 30 centimeter to 1 millimeter. 30 centimeter to 1 millimeter. It's getting smaller, but the frequency is getting higher, because frequency it's opposite of wavelength. We will explain later. Microwaves like radar, atomic or molecular research, aircraft navigation or microwave ovens, and infrared rays, infrared waves, we can say IR. The range is 1 millimeter to 700 nanometer. It's getting smaller. Molecular vibration spectra, infrared phototherapy, physical therapy, we are going to use it. Visible light, which is the light that our eyes could detect, it's the wavelength of it is between 700 nanometer to 400 nanometer, which is start from red to violet. Visible light, photography and optical microscope, optical astronomy. Ultraviolet wave, which is we are not be able to detect this wave. Except the visible light, we are not able to detect any of them. We cannot, by naked eyes, I mean. We cannot see them. Ultraviolet light, UV, it's between 400 nanometer to 16 nanometer. For the cleaning medical instrument, we can use it. And the identification of the fluorescent minerals, we can use them. And the X-ray, you know, we can use it for the medical examination of bones, teeth, and the vital organs, other types of the cancer. And the last one is gamma ray. Gamma ray, the range is between 0.1 nanometer to 10 to the power negative 5 nanometer. examination of the thick material for the structural flaws, treatment of the types of the cancer or food irradiation. We can use them. What you have to know the types of the electromagnetic waves and the applications. You don't need to know the range. I'm going to give you the range. You don't need to know the range, but you have to know the types of the waves and the applications. Types of the wave and application. Okay, now we are going to come to the relationship between frequency and wavelength, guys. Frequency and wavelength. As you see, speed of wave, C stands for speed of wave. This F stands for the frequency. This Greek letter, which is looks like opposite of Y, upside down Y, sorry, we call it lambda. It stands for the wavelength. The unit of the wavelength is meter, so it could be nanometer. We can change it. It could be micrometer. It could be centimeter. It could be kilometer. Whatever, we will change it to meter, guys. Frequency, the unit of frequency is 1/second, or we might say second to power -1, or we might say hertz. 1/s equal to hertz. So for the hertz also, we might have megahertz, gigahertz. So we're gonna have a prefixes in front of it, and we will change them to the basic one, to the hertz or to the meter. And you know the speed of light, the unit of speed of light is meter per second, guys. Meter per second. So that's the unit of frequency. Unit of frequency. Unit of wavelength is meter, nanometer, micrometer, centimeter, whatever. And we're gonna have this relationship between them. We can use this triangle, which is speed of light, wavelength, frequency. So if I ask you to find the frequency, you will say frequency equal to speed of light over wavelength. Or if I ask you to find wavelength, you're gonna say wavelength equal to speed of light over frequency, by using this triangle. So I understand from that one, if I increase the frequency, so wavelength will decrease. If I increase frequency, wavelength will decrease. Okay, now let's just solve an easy example. We can have this example, as you see, solve it. The AM radio band extends from 5.4 times 10 to the power 5 hertz to 1.7 times 10 to the power 6 hertz. What are the longest and the shortest wavelength in this frequency range? So it means this is the frequency, because it's written in hertz. That's the frequency. We need to find the wavelengths. So because it said wavelengths, we don't need to subtract them. We are just going to find two different wavelengths. Okay, so the first wavelength, the first frequency is 5.4 times 10 to the power 5. The second one is 1.7 times 10 to the power 6 hertz. And you know that the speed of light is equal to 3 times 10 to the power 8. We are going to use this formula. Which is wavelength equal to speed of light over the frequency. For the first one, you're going to divide it. You will get the first wavelength, which is 5.6 times 10 to the power 2 meter. And the second one, 1.8 times 10 to the power 2 meter. That is the wavelength that we are be able to find it from this frequency range. We have another example, which is the first example. The gamma ray bursters are objects in the universe that emit a pulse gamma rays with high energies. The frequency of the most energies bursts has been measured around the 3 times 10 to the power 21 hertz. What is the wavelength of this gamma ray? You have the frequency. We need to find the wavelength. You know that wavelength equal to C over F. Wavelength equal to C is equal to 3 times 10 to the power 8. And you know that 3 times 10 to the power 21, because that's the frequency. I know because it's written hertz and it tells me that the frequency. That's why I know. So wavelength 3 with 3, they will cancel each other, so just one remain. 21 goes to the up, it will be negative 21. So negative 21 minus 8, it's going to be 13. It's going to be negative 13 meter. That is the wavelength of the this frequency that the question gives us. Okay, that's the first question from the practice. For the second question, let's just send this one away. We don't need it. Now we are going to come for the second question, which is, in the second question, what is the wavelength range for the FM radio band, which is 88 megahertz to 108 megahertz, guys? We have, like the previous example, like the sample problem, we have a band. So it means in this case we are going to find the range. So the range should be between two numbers. We are not going to subtract them. We are just going to say F1 equal to 88 megahertz, F2 equal to 108 megahertz. So what is the wavelength 1? What is the wavelength 2? But there is an important note, which is wavelength 1 equal to C over F1. C equal to 3 times 10 to the power 8. F1 equal to 88 megahertz. We know this mega stands for 10 to the power 6. So instead of this M, I'll write down 10 to the power 6. Okay? And for the second one, for the second wavelength, we will say C over F2, which is going to be 3 times 10 to the power 8 over 108 times 10 to the power 6 again. Why? Because again it's mega. This is mega, that's why. So we are going to have the wavelength 1 and we are going to have wavelength 2. So first one is going to be equal to 3.4 meter and the second is going to be 2.7 meter. That is the first and the second question from the practice. And your homework is going to be let's just send this one away. The rest of the questions is going to be your homework. I mean that the question 3, it's going to be your homework. Question 4, question 5, and question 6. These 4 questions is going to be your homework. For the next lesson, I'm going to ask you about this homework.